So in this video, we're going to talk about how to solve problems involving exponential growth and decay. So exponential growth and decay, when we're working on these problems, we're going to need to use these two formulas. So if we have exponential growth, we're going to use that 1 plus r to the t. And if we have exponential decay, we're going to use the 1 minus r to the t. Remember that a is the initial amount, r is the rate of change as a decimal, and t is going to represent time. So notice in these formulas, t has taken the place of x. Because when we talk about these problems in real life situations, t is usually the independent variable. So what we're going to do to solve these problems is you're always going to start off by determining whether you have exponential growth or decay. And that's going to determine what form of the formula that you use. Then you're going to substitute in the values of a, r, and t, and remember to convert r to a decimal. So another place that we use exponential growth or decay is when we're talking about compound interest. So if you have a bank account or if you've ever deposited money in an account, you know that when you save money in a bank, you earn interest, okay? So it's a percentage of the amount of money you have in your account that the bank will give you just for having your money deposited in their account. So interest can be compounded. So you can earn money as interest based on the principal, which is your initial investment, but also on past interest, okay? And so that's the idea of compound interest. You're getting interest on your deposit as well as the interest that they've given you. So when you have compound interest, they can have what's called different compounding schedules, okay? So there'll be different time periods where they calculate the amount of money you have in your account, and then they do like a percentage, and then they figure out how much money to give you. So some places will compound interest annually, which is once a year. Some places do quarterly, which is 4 times a year. Other places do monthly, which is 12 times a year. Weekly will be 52 times a year, and daily will be 365 times a year. So what we do is we use a modified version of this formula, okay, to calculate compound interest problems. So remember, our formula is y equals a times 1 plus or minus r to the t. Well, what we have to do is we have to use this form of the formula, the a times 1 plus r over n to the nt, because n represents the number of times the interest is compounded. And the reason for that is because usually what they'll give you is the annual interest rate, okay? But remember, annual is how much you make in a year. So if your interest is compounded weekly, that means the weekly rate is going to be a little bit different, okay? So that's why we have to make an adjustment to this formula when we're talking about different compounding schedules. So let's look at an example. So it says that Juanita deposits $4,000 into a savings account that earns 2.75% annual interest, and that's compounded quarterly. If she makes no other deposits or withdrawals, what will be her balance after another 15 years? So she deposits $4,000 and she gets 2.75% annual interest, compounded quarterly, and no other deposits or withdrawals, so her balance in 15 years is what we need to find. Okay, so we're going to use that formula that y equals a times 1 plus r over n to the nt. So let's figure out these values. Okay, so we have a, which is our starting value. That's going to be her initial deposit. So that's going to be that $4,000. And then we have r. So it tells us that r is 2.75%, which we need to convert to a decimal. So when we do that, we have 0.0275. And then we have n. So n is the number of times it's compounded. So compounded quarterly means we have 4 times a year. Okay, so the value of n is going to be 4. And then we have the value of t. It tells us to think about what's happening in 15 years. Okay, so now all we need to do is plug everything into this formula. So we have y equals 4,000 times 1 plus r, which is 0.0275, over n, so that's over 4, and that's to the 4 times 15, right? N times t. So now I'm going to have to do some simplification before I can enter this in my calculator. I have 4,000 times 1 plus, and if I do 0.0275 divided by 4, that is going to be 0.006875. And that is to the 4 times 15. I'm going to go ahead and simplify that. 4 times 15 is just 60. So this is y equals 4,000 times 1.006875 to the 60th power. Okay, so now you can enter that all in your calculator. So you do 4,000 times 1.006875 to the 60th power. And that tells you have 6,033.835. Since we're talking dollars and cents, we're going to round to the hundredths place. So that is going to be $6,033.84. So that is how much money she will get if she leaves her money in that bank for 15 years. Okay, because what she's doing is she's earning interest on that initial $4,000 deposit, plus she's earning interest on the interest that she gets 4 times a year. So now you can go ahead and pause the video and try this example on your own. So in this example, $3,000 is invested in an account that earns 9% annual interest compounded daily. So how much money will be in the account after 5 years? Okay, so the starting investment A is $3,000. R is 9%, which is 0.09. N is 365 because we have compounding daily, so 365 times a year. And then we have T equals 5 years. So if we plug everything in, we have 3,000 times 1 plus 0.09 over 365, and that's raised to the 365 times 5 power. So when we simplify this, we get 3,000 times 1.000247, right? Because you do 0.09 over 365 and then add 1 to that. And then that's going to be raised to the 1825 power. So when you enter that in your calculator, you should get 4,708 and 0.3222. Remember, once again, we are talking about dollars and cents, so you want to round to the nearest hundredths place. So that's how you get $4,708.32.